Hi guys, Mr. McHugh here, bringing you another video on the properties of angles, and this one's going to look at what are the definitions, of the various trigonometric functions. And we're going to look at 6 basic trig functions today. And there's more than these 6, but when you're first starting out with trigonometry, these 6 are the best and easiest to start with. And the easiest way to begin is to think about these trig functions in the relationship to a right triangle. And the definitions of the trig functions hopefully will make sense when we look at the different parts to the right triangle and how those parts relate to what we're calling these 6 trig functions, which we'll get to in just a second. But every right triangle has 3 sides, and the side that's opposite of the right angle here is almost always labeled with the letter C, and that side is called the hypotenuse. And we'll refer to that both as side C, but also as the hypotenuse. That's its official name. And when you look at the angles, there's 2 angles that are not the right angle. There's this angle down here on the bottom and the angle up here at the top. And we could talk about either of those angles, but for this example, I've chosen to call the bottom angle theta. And the 2 other side lengths that aren't the hypotenuse are called the legs of the right triangle. And the legs we're going to label in their based on their relationship in their position to theta. So you'll see side A is opposite of the angle theta. It's on the far side of the triangle, across from theta. And so its position makes it the opposite side. So in our triangle, side A is our opposite side. In side B, leg B here forms our angle theta with the hypotenuse. You can see how B and the hypotenuse C come together to form angle theta. So the side that forms the angle is called the adjacent side. So we know the side lengths A, B, and C. Those are commonly used in the Pythagorean theorem in calculating their side lengths. We're now referring to sides A, B, and C with their names hypotenuse, opposite, and adjacent according to their relationship to angle theta. And that's important because the 6 trig functions that we're about to define are all based on the relationship of the sides' positions to the angle theta. The first trig function is called the sine function, S-I-N-E, and we abbreviate it with the letters S-I-N. So we say the sine of theta, and the value of the sine of theta is the ratio of the opposite side length divided by the hypotenuse. So if you know the 3 side lengths to the triangle, plug in the opposite length, divide it by the hypotenuse length, whatever that fraction is the value of the sine of theta. The second trig function is the cosine. And the cosine is abbreviated COS. And the ratio for the cosine of theta is the adjacent side length divided by the hypotenuse. So sine is the opposite over hypotenuse, cosine's adjacent over hypotenuse. The third trig function is called the tangent. And the tangent is abbreviated TAN. And the tangent of theta is the opposite side length divided by the adjacent side length. So these 3 are the foundational sort of building block trig functions that we normally introduce in Algebra 2, sine, cosine, and tangent. And you've probably heard this before, but the easiest way to remember the ratio of the side lengths is to think of the saying SOHCAHTOA. And SOHCAHTOA is the so part is the sine is the opposite over hypotenuse. There's your so. Ca is the cosine equals the adjacent over hypotenuse, so ca. And then the toa part, tangent, equals opposite over adjacent. So if you can remember SOHCAHTOA, you should have these three trig function values in the ratio of the side lengths down without any trouble. SOHCAHTOA. But that's just the first three. There's a total of 6, I said, in this video we're going to cover. So what are the other 3? The other 3 are built and are similar to the first 3. So the fourth one we're going to talk about is called the cosecant. And the cosecant function, can't use COS, that was used for the cosine, so we use CSC. The cosecant of theta is equal to the ratio of the hypotenuse divided by the opposite. The fifth trig function is called the secant. And the secant, abbreviated SEC, secant of theta is the hypotenuse divided by the adjacent. Okay, and lastly, we've got the cotangent. Abbreviated COT, cotangent of theta, and that's equal to the adjacent over the opposite. And if you haven't noticed, by my clever color coding, the cosecant and the sine functions, these go together. The secant and the cosine, these go together. And the cotangent and the tangent go together. And by go together, what I mean is they are defined using the same side lengths, but they're reciprocals of each other. So the cosecant is really the reciprocal of the sine of theta. The secant is really the reciprocal of the cosine of theta. And the cotangent, of course, the reciprocal of the tangent of theta. And those are the definitions of your 6 basic trig functions and how they relate to the side lengths of a right triangle.